Okay, so for this problem that I'm going to do, it is the second problem for my homework number 3 for mathematical physics. And the question states that the time-independent one-dimensional Schrodinger, should be Schrodinger, equation for the harmonic oscillator is, and it has a Schrodinger equation that we all know and love, says making the replacement that letter is the Greek letter. I had to look it up because I didn't know. It's xi. Xi, that's how you pronounce it. Anyway, equals x square root. So we're making this replacement with xi, and that equals x square root of m omega over h bar, and k equals 2e over h bar omega. And looking for solutions of the form, so this is telling you what the psi is. So the psi of this xi equals some function h of xi e to the negative xi squared over 2. Whew. Okay, then it's basically saying that we need to show that it reduces to this equation number 2. And then it says this can be rewritten in our Sturm-Liouville form as the Hermite equation, which is equation number 3. And so the question is asking that we need to show how equation 1 leads to equation 2, and that equation 3 also reduces to equation 2. Once we're done with that, we're going to say, what's the orthogonality condition? Meaning, like, how do we know it's orthogonal? For the eigenfunctions of xi, of the h of xi, and then we're going to find a recurrent expression for the coefficients of the Hermite polynomials. Okay, so let's get straight into it by writing down our Schrodinger equation, h bar squared over 2m. It's a full derivative because it's one dimension. So d squared psi over dx squared plus 1/2, and this I guess is representing our potential, m omega squared x squared psi equals e psi. All right, so here's the Schrodinger equation we're starting with. And then, so the replacements we're making, let me go ahead and write these down. So we have our xi is equal to x square root of m omega over h bar, and k equals 2e over h bar omega. Yeah, h bar omega. Great. And then we're looking at a solution in the form of psi of xi equals h. This is not h is the constant. H is just a random letter. And h of xi, oh my gosh, so bad at drawing that. Yeah, times e to the minus xi squared over 2. Okay. There we go. And then, yeah, we're looking for a specific form, but let's just see if we can work through a couple of things to simplify this. So first of all, it's best to so we have our new psi function, and so we need to find out what the second derivative with respect to x would be. So d dx of our xi, right, is going to be the derivative of this guy. And so that's going to give us just square root of m omega over h bar times d over dxi okay? And so to get our second derivative, d squared over dx squared, that equals the derivative with respect to x of m omega over h bar d dc. And this is not 0 because this is equal this up here, okay? So we can actually just turn this into m omega over h bar, because it's this quantity squared, times d squared over d c squared. Now this is important. So this is what replaces our d squared dx squared, okay? So we'll go ahead and just rewrite it again. Negative h bar squared over 2m times m omega over h bar. Then we have d squared over dc squared. Now we have it in terms of our c instead of x, but we have to replace this here, this term, this middle term, with our c here. So we can pull out the 1/2 m omega squared, just to make it easier. And so what is that? Plus, yeah, plus. Oh, and this is psi here. Okay, we're just going to leave it as psi for now. We're not going to fill in the psi yet. Plus 1/2 m omega squared. And then we have an x squared. So if we just square this c term, we get x squared again. So what we want is c squared. But to do that, we're going to need an h bar over m omega. So we do this, h bar over m omega c squared, okay? And that gives us our x squared. So now we have everything in terms of c instead of x. Then we have psi equals e psi. Okay, now we're just going to set this aside for now because we got to figure out our size, okay? So let's change color and figure out our size. Okay, so remember psi, again, is some function h. This is a function. I'm not going to write it, but this is a function of, I'm not going to write it every time, of c times e to the minus c squared over 2. Okay, remember that's what this is? So now we have to find our derivatives. And so there's going to be a chain rule involved, right? Because this is a function of c, and so is this. These are both functions of c, so when we take our dc of psi, that's going to equal psi prime, just for the notation is simpler. And that's going to equal this. We're just going to call it h prime for simplicity, but it is the dc of h, okay? Times e to the minus c squared over 2. I'm so bad at drawing that. Plus, and I know it's going to be a minus because of the chain rule. We're going to have 2c divided by 2, so just 1 c times e to the minus c squared over 2. Okay, and we can, it makes it a lot easier if we factor out this e here. So, okay, anyway, so we get e to the minus c squared over 2 times h prime minus c, okay? Good, I did that right? I think so. All right, so that's our psi prime. Now we need our psi double prime. Let's give me a little bit more space, and I'll change colors again, just to really contrast. Our psi double prime is going to be, and again, we're going to have a chain rule again, okay? So it's going to equal the derivative of the, not chain rule, product rule, derivative of the first, which we already know is e to the minus c squared over 2, okay, times the second, which is h prime minus c. Okay, plus the first one, which is just e minus c squared over 2, times the derivative of the stuff on the inside, which is going to be h double prime minus 1. Okay, did I do that correctly? Let's see if I did that right. Yeah, I believe so. Yeah. Let's see here. Plus da da da. Times, see if I did this correctly. H prime E. Okay. Yeah, I think this all works out. Okay. So in the end, we can factor out this e to the minus c squared over 2. Then we're going to get minus, yeah, okay, yeah. So this all works. This works. This works. H prime c plus c squared. That's just a squiggle at this point. Plus h double prime minus 1. Okay. So I'll put a bracket because this goes on all that. So, okay, good. So this is our psi double prime. We have it. Good. Now we just have to plug everything in. Okay. We got to plug everything into our equation up here. So we got to plug our psi in psi prime into this Schrodinger equation. So first, let's just look at some things. We can cancel out an h bar, cancel out an m. We can cancel out an omega and an m. Okay, and let's just write that out. So we get minus h bar over 2 times omega times our psi double prime, which is, I'm just going to write it all out, e to the minus c squared over 2 times minus h prime c plus, really sorry about the poor Okay, plus h double prime minus 1. Okay, that's our first term. Plus 1/2 h bar omega plus 1/2 h bar omega, right? That's what we have left up here, times c squared times c squared psi, which is h e to the minus c squared over 2. Okay, and all of that is equal to e of psi. All right. So, and then psi, remember psi is this, so e times r. Yeah, I'm not going to fill it in yet, okay? So we need to rewrite everything, combine some terms. But something that we need to do is remember that our this is what we don't want e in our final expression. Our final expression is going to have the form with only k. There's not going to be e. So we want to convert the e into a k basically, and k equals 2e over h bar omega, 2 big E over h bar omega. That's what we want. So let's go ahead and basically multiply everything by 2 over h bar omega on the entire equation, and then see what we come up with. All right, because that's the form we want, because that equals k. Okay. So 2e, so we're multiplying everything by 2 over h bar omega. Okay, so you can notice right away that when we do that, the 2 over h bar omega cancels this. So we get just a negative e to the minus c squared over 2 times minus h prime c plus c squared plus h double prime minus 1, okay? And then plus, and we multiply by 2 over h bar omega. So you can see again, right here, up here, that's going to cancel out as well. So then we just get c squared times h times e minus c squared over 2. That equals k. Now we have k times he, this thingy, okay? All right, now the good news is all of these terms have this e to the c squared over 2. All of these terms have it. So now we can divide out that term, which is awesome. So we can divide out this term, this term, this term, all of it. The h's have to stay for now. The h's have to stay for now. We'll simplify that. Is there anything else we can simplify? Yes, so this is going to turn into a minus c over 2, or c squared, and this is a positive c squared, so this can cancel right away. So we're going to get a minus h double prime plus h prime c plus 1. And then let's move this over to the other side. We get minus kh equals 0. Okay, so we're almost there. We needed h double prime minus 2. Oh, did I drop a 2 at some point? I'm interrupting the video just to show you the correct derivative. So this is the correct one. As you can see, we have our psi here, psi prime, and this is what I had done. I had dropped this hc term. So now when you take this second derivative, you have the derivative of the first, which is derivative of the first is just minus c e to the minus c squared over 2 times the derivative inside of this. Okay. So times this, actually, times this, h prime minus h c, all right? And then plus this e term times the full derivative on the inside. So to take the full derivative on the inside, we'll just do it separately. It's going to be h double prime minus, now we have a product rule, right? H prime c, so minus, yeah, h prime c plus h, and then the derivative of c is, c with respect to c is just 1, and then that gives us this. So then we have that times h double prime minus h prime c minus h, and then that is where our second term is going to come from. So I'll go ahead and now skip back to that part. Thank you. This is actually the exact form we need, which is this double prime h over c squared minus 2 c dh dc plus k minus 1 h equals 0. So that's how it's done, even with the derivation error. Moving on, it's going to say show how equation 3 leads to equation 2, so we'll just go ahead and do that. So this is going to be equation number 2, and then equation number 3 is d dc, and this is our SL form, the Sturm-Liouville form of the equation. It's the same thing, so we're just going to show how it is. Minus c squared, this time not over 2. We have dh over dc, okay, plus k minus 1 e to the c squared h equals 0. So this is pretty easy, straightforward. All we're doing is a derivative. And so you're going to have a chain rule, or not chain rule, but product rule. So we're doing this. So we have the derivative of the first, which is minus 2, because it's not divided by 2 this time, c e to the minus c squared. Okay. So the derivative of the first one, which is this, plus the first one minus c squared times the derivative of the second one, which is d squared h over d of c, and then plus the rest stays the same, k minus 1 e to the c squared h equals 0. You can probably see what we're doing already, but you just divide out this e term and because of, let's see here. Let me look at my notes. I'm gonna cheat and look at my notes to see how that works here. Yeah, so you're taking d. Right. So you actually have this partial that I forgot. This dh. I was making the same mistake. So you need a partial derivative here, and that's part of the chain rule. Dh of dc. You need that to go here. Okay. That's what I forgot. I forgot the chain rule again. All right. So we write it all out after we factor out the thing. And we're going to get d squared h over dc squared. Okay. Minus 2c. Then we have dh dc because of the chain rule. And then plus k minus 1 h equals 0. And this should be our equation number 2, and it is. Okay, so our equation number 3 equals number 2, and we're done. So now, with this result, we're supposed to ask what the orthogonality condition for the eigenfunctions are. And so, since it's in the SL form, there's an entire proof for Sturm-Liouville that states that everything of that form is orthogonal. So all you have to do is just say, this can be written in this form, number 3, therefore it's orthogonal. So that's it for that one. Now to find the recurrent expression, this is the last part. So what we have to do is we have to take h and we have to make it this, for the Hermite polynomials, or for Laguerre polynomials, and for most other polynomials, they all take the same form, more or less. We're going to say n equals 0 to infinity. And we're going to turn this into some a sub n times our variable, which is c. And have that be to the power of n. And we're just going to put it in our ODE that we've made. So first we need to find h prime. That equals, sum is going to start 1 later. And we're going to have n, a to the n, c to the n minus 1, and h double prime. It's also known as the Frobenius method. And then this is, again, n starting at 2 this time, infinity, n minus 1 times n a to the n. All right, we're just going to plug that into our ODE. So we have sum 2 n times n minus 1 in, n minus 2. This is a to the n, c to the n minus 2 minus 2 times the sum into 1 to infinity. Now we're going to absorb a c in our our sum here. So it's going to be n a to the n c to the n minus 1 plus 1. It's just n. And then we're going to add plus, we'll just keep this like this, k minus 1, sum n equals 0 to infinity of a to the n c to the n. The way that I do this, I just have, I want there to be a c to the m, and that means n minus 2 equals m. When we write everything in terms of m, we can exclude the sum now and just write it like this. We have m plus 2, that becomes our n, and our n minus 1 becomes m plus 1, times a to the n plus 2 times c of m. We're getting rid of our sums now, so they're irrelevant. Minus 2 times m, this becomes our c of m, so n just turns into m. A m c of m plus k minus 1 a m c of m. Get rid of all of these c's. Put the n plus 2 on one side, everything else on the other side. So we get a, we're solving for a of n plus 2 for our recursion relation. That's going to equal 2a, nope, let's rewrite this. I'm just going to go ahead and do this now. That's going to equal a sub m 2 m minus k plus 1. Yes, okay. And then that is over m plus 2 times m plus 1. And that is our recursion relation, and that is the end of this very long problem. Thank you very much.